Okay, adding and subtracting polynomials today. So here's an example. Add 3x minus 4. I have to add it up to 2x plus 5. Okay, so yes, I put brackets around these, but I'm just showing you I'm going to chunk this polynomial and add it to this other chunked polynomial. These brackets actually can just drop because you're not doing any different math to it other than just adding. Okay, nothing different happens with adding. Okay, so now what do? Just like yesterday, we started saying, hey, let's identify like terms. So I'm going to say that those two terms are like each other. Did you notice how I also included this sign in that circle? Okay, and then I'm also going to do another group. Okay, those are like each other. Do you notice how I'm also putting that sign inside that bracket so I can see that sign as well? So when I mean that, I mean I put the -4, -4. Okay, so here we go. We're going to finalize the answer here. So if I have 3 x's and then adding 2 more x's, I have 5x and plus 1. What is 1 called? Started with a C. I asked you it again yesterday. It's a constant, yeah. Why is it called a constant? It never changes. It doesn't have a variable. Okay, so here I go. This is just adding, so you can actually drop the brackets. When you add, there's nothing that would end up changing. Okay, now think about what looks like anything else. So 2a is a like term with -4a. So let's write that down already. How many a's do we have? -2a. And I have a constant and another constant, so I can put them together. So -1 plus 6. Careful with the signs on that. +5. Okay, and B. This is adding, so I don't have to change anything. Adding is just normal. You know what? I really do not like when they use T's here. Do you notice how I'm trying to make my T's like cursive T's so you can see that they're not? Okay. Okay, so I'm going to look for like terms again. So here's something I found that's like each other. So there was a 3t squared plus a t squared. So now I have 4t squared. I have a -5t plus 2t. So together those can be -3t. Am I done? No, why am I not done? There's a +1 there. There was no like terms with it, so it just gets lonely, but you still have to include it. Okay, we're going to talk about, we're going to get into subtracting here. So, opposite. When we subtract, it ends up doing adding opposite. So we can talk about what is an additive inverse. Okay, so when we're talking about terms, if you start with a term and you add the opposite, what would it make? When you add something and its opposite together, it should make 0. When you add two opposite things together, it should be 0. So there's an example, exactly. A 2 plus the opposite, a negative 2.
Okay, I get it now.
So 2 plus negative 2, like this. So there's an example that Dom gave us. 2 is a term, and then if I add its opposite, they should always add to 0. Okay. So what is the opposite of 3x? Negative 3x. This is a, what if I had to classify this term? What is the name of it? Is a word when it has just one item? Monomial. What is the opposite of a negative 2? Positive 2. Okay, this is a binomial now. So what is the opposite of this binomial? Give us half of it. Negative 4x. Easton, finish.
Plus 1.
Plus 1.
Yes.
Okay, think about it. If you were to put those together, would it zero out?
Yeah.
Okay, so trinomial. Trinomial, so opposite, and it's everything. You go ahead. Let's see. Try it on your own. Opposite, everything. Are you going to answer, Dom?
Yes, can I answer, please?
Do the first. Go. Easton, second.
Plus 3a.
And then a third person has to finish it. No, you already did the second one. Shannon. Minus 2. That is an opposite. Okay? And I know if I put that together, it actually would make a 0, right? Okay, go ahead. This is a show you no box, so you don't get my help on it. Check out your answers. Are they the opposites? Did you do the same as me? Opposite. Okay, so every time something looked plus, it's now minus. Every time something was minus, it's a plus. Okay, oh, this is kind of confusing, this question, because it says to subtract this from this. So which one of them would I write first?
The 3x.
3x minus 4. So I'm subtracting this from that. See that wording? It's kind of a little bit confusing. Okay. Now, I want to just quickly go back to talking about integers. Okay, this is just let's just go back to what's going on with integers. Do you remember me talking about subtraction with integers? And I said, okay, forget subtraction. Instead of subtracting, you're going to add and then change to opposite, right? So this was Okay, do you remember that from integers? Okay, or if I did something like this, 10 subtract 6, okay, can you change the look of that question to always follow the same format? Instead of subtraction, you're going to change it, add, opposite. Okay, these are the same meaning. Subtracting 6 and adding a negative 6. Does that make sense? That's doing the same math. 4. Okay, so that's what this is all about. But instead of numbers, integers, we're going to be working with letters and all these things, right? Okay. Here we go. So there's nothing going on with this bracket, so I'm just going to drop it. 3x minus 4. Instead of subtracting all that stuff, I'm going to add the opposites. So I'm going to add a negative 2x, and I'm going to add a negative 3. Okay, here's a question for you to think about. This subtraction sign, is it applying and doing stuff to everything in the bracket or just the first item? When you deal with brackets like this, the subtraction sign is affecting everything in the bracket. That's why there's a bracket there. Okay? Versus if you ever just saw this, now it's not affecting the 3 because it's not in a bracket. Okay? So brackets with this means it's including everything. Okay, now we finish. This is like this. So what do I have together there? 3x and a negative 2x make, what did I do?
Yeah, okay. So, wait.
I add opposite, add opposite.
Yeah. I'm just wondering why you flipped around, because at the start it says 2x plus 3, but then in your example you started with 3x subtract 4.
Because of the wording. Subtract this from this. Yeah, so if I ever said just numbers here, if I said, can you subtract 5 from 12?
Then 12 subtract 5.
12 subtract 5. Yeah, it's just that wording. It's kind of awkward. Okay. And here's me identifying something else that's like each other. So what is this number going to be? There was a subtract 4 and a negative 3. So now it's a subtract 7. Okay, let's do these together. I know it says show you know, but let's go more here. Okay, first bracket is just regular. There's nothing to do there, okay? So 2x subtract 3. You can just leave it. Okay, so now this bracket is getting subtracted. So let's do this idea. I'm going to add opposite stuff. So what kind of x should I have? Plus x. And then there's a plus 2 here, so I don't want plus 2 anymore. I want a minus 2. I don't care how you write that. Some of you might write add a negative 2, and some of you might just write subtract 2. Okay, that's okay. I don't care how you write it, as long as you're understanding that this says plus 2, but now I got to be opposite of that. Okay, because we learned that these are the same ideas. Okay, here we go. Like, there was a 2x plus an x together, 3x, and then as a number, this number and this number. Okay, here we go. First bracket. there's nothing different in front of it, so nothing would change. Oh, I don't like this. This is a subtraction. Well, so what does subtracting make me do? Everything opposite. So this was a positive 2x squared. So now it's a negative 2x squared. So you can write that, or you can write that, whatever makes your brain work. And then this was a negative 3x. So now it's going to be a plus, plus, because you would have to add a positive. Instead of subtracting a negative, you add, and then the opposite thing. And
then
add. Add 1. That's the opposite. Okay, so the application of the subtraction, do you see how everything I've highlighted is opposite? Okay, so finalize stuff here. What does it make when you group your like stuff together? Uh, 3x squared, a negative x, and a positive 3x. 2x. And then there's a 4 and a 1. They're both plus, plus. Okay, I might go a little bit more here because I just want to see. Okay, this isn't in your notes, but you guys have a little bit of room on the bottom of that page, right? Okay, I want to talk about perimeter. Do you guys know what the word equilateral triangle means?
Same degree.
All the sides are the same. Okay, so I want you to get me the perimeter of this triangle.
2A.
So if I am given this word, hey, this is an equilateral triangle. All the sides are the same. So if this is 2a minus 5, this is 2a minus 5, and this is 2a minus 5. So I would say this side plus this side plus this side is the perimeter.
Do you want us to give you the equation for, or do you want to give us the expression for it, or the answer?
I want an expression. Yeah.
Could you just go 2a 5 to the power of 3?
Not to the power of. You could multiply it by 3 though. That's our next lesson though. I will show you that though too. Okay, so is there anything I have to worry about with opposites here?
No.
No, because there's plus, plus, so I just do everything normal. Okay, so what's like each other? So there's a 2a, a 2a, and a 2a, so add, 6a.
And plus negative 15. I don't know.
Yep.
Okay.
So there's subtract 5, subtract 5, subtract 5. Okay. So Easton had said plus negative 15. That again is the same thing. If you write me that, it's the exact same thing. That's a perfect. I'd give you perfect score. It doesn't matter on that. Okay. Okay. So Henry had like an extra idea here. which was great because that's actually going to be our next lesson, but I'll show you. So he said, well, if this side's the same, and this side's the same, and this side's the same, what happens if you add together three things that are the same? What's another idea?
2, 8,
You just triple it. You times it by 3. Okay, so this is what we're going to actually get into next lesson. So we're going to think ahead here. This is next lesson. So I times this. Do you know why I had to do brackets though? Does that make sense? Because you're timesing that whole thing. You're not just timesing the 2a, you're timesing that entire thing. So that means brackets. Okay. Now, just like we did this negative sign, we had to change everything in the bracket there. It applied to everything. This 3 also does that same thing. It applies to everything in the brackets. So what if I times this by 3?
6a.
6a. If I apply that timeser,
Times
okay, and what do you get if you apply that one?
negative.
oh, we just got cold.
Did it work out the exact same as when we added stuff? Look at that.
Wow. Epic.
Epic.
Epic games.
You're so
Okay, I'm going to give you another question here.
That's not an equilateral.
It's not equilateral this time. So all my sides are different things going on. Okay, I've told you this side, I've told you this side, and I actually told you over here what the perimeter was. So we're going to go opposite stuff here. I would actually like to know what's my third side on this triangle then.
I don't know what it is.
Okay, so does anybody have an idea how to get to this side? What's your ideas?
You add your two sides that you know, and then your perimeter, you take your perimeter and or you take your answer of the two sides you know and then subtract it by your perimeter, or, yeah.
Yep. Okay, so that's one idea. I have two ideas. So Ethan's idea was, hey, let's add what we have so far, and then once we figure that out, we could do a subtraction from this. Okay, you could also do this, almost the exact same idea, where you start here and subtract this and subtract that. You know what I mean? So you could add these together and then subtract the whole thing, or you could subtract them each separately. It doesn't matter. It will get you to that same idea.
Is it 17x plus 6?
Oh, I don't know. I haven't got. You're way ahead of me. I'm just thinking about my strategies right now. Okay, what do you want me to do here? Should we group this addition and then subtract, or do you just want to subtract and subtract all of them individually?
It's like 3x.
Okay, so you want to add this together right now. Okay, so x plus 2x plus 10. I'm going to add up what I do have.
3x plus 10.
No.
So 3x plus 10 is how much I have now.
You get used to 17x.
So if I took my whole perimeter minus what we have up to, okay, and here we go. On this first item that I wrote here, regular, the brackets, there's nothing going on to the brackets, so I'm just going to drop it. Is there something going on to this bracket? Yeah, a subtraction, so I have to do some application. I have to do some application to that, so everything in this bracket is now going to be opposite. So that's opposite, and that's opposite. So what is this missing side? So let's do some grouping. 20x together with a subtract 3x makes 17x. I can do like terms on this. Plus 6. Okay, so these are some applications with adding and subtracting. I'm not sure if you're going to run into this word on your homework, but I know that it's on your test. You ready? The word is regular.
Regular. All sides are equal, I think.
Yeah. So in math, I just want to talk about this word.
Hold on, X is on regular. So how did we know? Shh.
So you might run into this, I'm not sure on your homework, but I did put this word on your test. So the word regular, okay, means everything is the same. All the sides are the same.
Irregular.
Okay? Do you guys know hexagon
Yes.
is?
Sides.
Isn't that
6.
what the U.S. uses to do their military stuff?
Yeah.
That's the pencil.
Pent? Pent?
Thing,
No, it isn't. What's a pent? Pent is 5. That's not as fun to draw. It's harder. That's a pent.
That's a house.
That's
Yeah.
one plate.
So how should the side of the
So
Talking about guys, it's one plate.
regular, the word regular means this. That all those sides are the same. Have you guys seen tick marks like that before?
Yes.
Congruency.
That means
Congruency.
they all have the same size.
They all have the same length. Okay?
Yeah.
I think most of that stuff now is going to get you done your homework. Okay?